Good afternoon to all of you and welcome to today's live coaching classes. We are starting with a very important chapter in dispersion, and that is on standard deviation and quartile deviation. So let us look at the coverage for today. In the last session, we had already covered the basic idea of dispersion, and you may recollect that dispersion means scatteredness of data, the extent to which data is spread out, that is dispersion. And then we proceeded to cover our discussion on the different measures. There are two types of measures. One is the absolute measure and the other one is relative measure. Relative measure is usually used for the purpose of comparing the nature of two classes of or two groups of variables. And when it comes to the types of measures, we had already covered range, which is the difference between the largest and the smallest observation, and mean deviation. Based on range and mean deviation, we have calculated coefficient of range, where the coefficient of range, you may remember, is the range divided by the sum of the two extreme values, the highest and the lowest value, multiplied by 100. And coefficient of mean deviation from two angles. First is we had computed the coefficient of mean deviation from the mean and again from the median, because mean and median both are measures of central tendency. Therefore, the coefficient of mean deviation is calculated keeping the base. One type is from the mean and the other type is from the median. Now, in today's coverage, we are coming into the last two important measures of dispersion, and that will be standard deviation. And standard deviation is a very useful concept, so we will understand the meaning of standard deviation, the formula which is used, the properties, and as usual, the advantages and the disadvantages of standard deviation. Standard deviation and variance both are very important for your understanding. In fact, the square of standard deviation gives us the measure of variance. Now we have the last concept in this chapter on dispersion, and that is the understanding of quartile deviation, the concept, the formula, properties, advantages and disadvantages, and then we have the questions from the MCQ, the chapter end exercises, and we will take some questions from the additional question bank which is provided at the end of this particular chapter. So with this, we shall be completing the dispersion chapter. We are having, this is the second session on the dispersion, and with this we shall be completing the chapter on measures of dispersion. So now let us discuss about what is standard deviation. We had already covered the description, the calculation for mean deviation. We know what is mean deviation. So the deviation of each of the variable from the central number, or you can say the central quantity, or of course it is a measure of central tendency, so it can be the mean or the median. And we calculated the total deviation and divided it by the number of total observations, the frequency. So that gives us basically the mean deviation. Now in standard deviation, it is a very simple and connected concept. Standard deviation for a set of observations is defined as the root mean square deviation. Square root, okay? Square root mean square deviation when the deviations are taken from the arithmetic mean. So here, in case of standard deviation calculation, we shall consider only the arithmetic mean. We will not calculate any type of deviation from the median. So please note, it is only going to be the deviation from the mean, right? From the arithmetic mean. Again, mean means here arithmetic mean, because we are not going to consider geometric mean or harmonic mean for the purpose of standard deviation calculation. So the formula is given by, you can see the sum of all the deviations, the square of the sum of the square of the deviations of each of the observations from the mean, that is x bar, and therefore we get sigma xi minus x bar whole square by n, and we have to get the square root. So this square root gives us the standard deviation. So standard deviation is the root mean square. Okay, root mean square deviation. We will see this through an example and it will be very clear. Now, let us take this case. We have to find the standard deviation of 7, 9, 16, 24, and 26. So let us try to calculate this simple example first. We will also take frequency distribution. In this example, it is just few observations. There are no frequencies which is given. So let us try and solve it. So first we will find out, we will create the table. So step number 1 is to draw the table so that it helps us in calculating. So first is the value of x. We have 7, 9, 16, 24, and 26. So we have altogether 1, 2, 3, 4, 5. So n is equal to 5. The number of observations we have is equal to 5. Now comes the next step. We have to find the deviation. But then deviation from what? Deviation from arithmetic mean. So let us try to calculate the arithmetic mean first. How to calculate the arithmetic mean? We just find out the sum. So the sum is equal to 7 plus 9, that is 16 plus 16, that is 32, 32 and 24 plus 26, that is 32 plus 50. So we are getting 82. The sum is 82. So please try to do this problem with me. The solution is there on the slide, but then let us try to solve it first individually and on our own, and then we will see the solution. So 82 is the total sum, and we have 5 observations. So the arithmetic mean is equal to 82 by 5. That gives us 82 by 5. So let's just use the calculator and check. It comes to how much? 82 divided by 5, we are getting 16.4. So the mean is 16.4. This is x bar. So please note this is x bar. Now we will calculate the deviation. The deviation is given by x minus x bar. Please note this. I'm just drawing a line here to show the calculations. D is equal to x minus x bar. So first one is 7. So 7, that means, please note here we are going to consider both the sign. It's both the signs. That is, if it is positive, we will take it as positive. If it is negative, we will take it as negative. Yes, thank you. Many of you, Jyoti, Ankit, thank you for calculating the mean. Now let us check the deviation. 7 minus 16.4. So I'm getting minus 9.4. Then you have 16.4 and here you have 9. 9 minus 16.4, you get minus 7.4. 16 minus 16.4, so this is minus 0.4. 24 minus 16.4. Next one is 24 minus 16.4. So here also we can calculate. It is 24 and 16.4, it is 7.6. 26 minus 16.4, this is a positive. So again 9.6. So we have got the deviations here. Okay. Now we will calculate the square of the deviations. So we have to find out the square. So let us just calculate it, a 9.4 square. So 9.4 into 9.4. You can just calculate and check. So we are getting 88.36. So this is D square, 88.36. The next one, if you see, 54.76, 0.4 into 0.4, just you will find 0.16. 7.6 into 7.6 comes to 57.76. And 9.6 into 9.6. So we get 96 into 96, that is 92.16. 92.16. So we add up all this. So this is the deviation. So we try to get the sigma d square. Sigma d square. That is the summation of all the, we have to take the summation of all these numbers. Okay. So once you add it up, we are getting 88.36 plus 54.76. You will get 293.20. 293.20. Okay. So now the formula is sigma SD is equal to square root of what? We will get this d square, sigma d square. So 293.20 divided by n equal to 5. Okay. So now if you see the lower part of the slide, you can see the calculation as per what we are doing. 293.20 is the total amount of deviation, square of the deviations divided by 5. So this gives us square root of 58.64, and approximately that gives us around 7.66. So we get the square root here, and this is the standard deviation. So please remember standard deviation, therefore this is the standard deviation is shown by sigma. Okay, so the way in which we write standard deviation is sigma. This is sigma. Okay, so therefore in this way we have first got the observations. We have found out the mean here, 82. Total is 82 divided by 5 because there are 5 observations. So we had got mean of 16.4, and then we are subtracting each of the observation. Okay, the formula is x minus x bar. So first is the observation, each of the observation, and then we subtract the mean from the observation. So x minus x bar, so we get this column, and then we square up this column, the square of the deviations, we add up the square of the deviations. This is the total amount here. So the sigma of the deviation square, that is sigma d square divided by n, square root of this will give us the standard deviation. So this is how we calculate standard deviation. Even if we use the other method, yes, 7.66, great. So even if we use the other method, say for example, assumed mean. So if we take assumed mean, there also we will get the same result. So just let us try and find out the assumed mean method. You can see here, assumed mean is taken as 16. So 16 minus, if you take 7, deviation is minus 9. For 9, the deviation is minus 7. 16 is 0. For 24, it is 8. And for 26, it is 10. So again, the deviations are squared, 294. Okay, so this is, we are using the second method, that is from assumed mean. And now we will see that the formula for, so here 16.40 was the mean in the way we worked it out here. And also in the second method, in case of the assumed mean, the formula becomes sigma d square by n minus sigma d by n whole square. So sigma d square, if you see, is 294 in this example, 294, and you can see sigma d has come to 2. So therefore 294, you can see 294 by 5 minus 2 by 5. So we are getting the same value, 7.66. So this is how we are doing it. Many of you have got it. Yes. Miss Hera Hussain, Abhi, Dhyanesh, Chandan, Komalakshi, Bhumika, Mansi, Priyanka, very good. Jyoti, excellent. Okay. 292.30, and from there we have got the mean. Okay, there's one question from Manisha. How to solve lengthy problems of statistics in the exam? Now, when it comes to the problems, yes, we have to understand the formula. Number 2, in the problems, you will find the problems may not be long. Problems may be, say, maximum, maybe 3 or 4 observations. Like here, we have 5 observations. So it will be like that. Also, looking at the past year's exams, there are some specific type of questions which we will do, of course, on standard deviation and quartile deviation, which is not based on this type of formula. It is based on that y equal to a plus bx type of formula, which we had done the other day. That means mean deviation of x is known, and the relation between x and y is given, the equation is given. You have to find the mean deviation of y, or the range of x is given, y equal to a plus bx is given, you have to find the range of y. So these type of formula based questions are also coming, and therefore in such case it will not be lengthy. It is just applying the formula, putting the value and getting the number. And in case you get this type of questions, Manisha, just practicing all these type of questions, the more you do, you increase your speed, and therefore in the exam also it will be easy. However, please remember, for these type of questions, you may not have any shortcut. You have to work it out in this way. Of course, here I am explaining each of the step. I am trying to make you understand. I am writing slow, speaking slowly so that you can follow. But in the exam, you don't have to teach anyone. So you just have to go on solving as fast as possible. So your speed, the way you handle the question, absolutely will be much faster. So definitely you will be able to solve the question within the given time. Okay, so we are going to see a lot of problems, lot of various types of problems which can come on this chapter on deviation. Now let us take the second the second stage. Standard deviation, we have some numbers, variable, the values. You can see problem 1 in this slide, and we are given some frequency. So how to handle, what to do in this case? So let us try to work it out. So we will take the table, we will create the table once again, and we are trying to solve it. The first one I hope is clear. Now we will try to solve this. Here we have frequency. Okay, so the frequency means that again a table has to be drawn. In this case, what we will do is we will try to first write down, we will take assumed mean. We will try to assume mean and then we will go ahead. So let us take the problem first, X and F. So F is the frequency, X 10, 11, 12, 13, 14. 10, 11, 12, 13, and 14. And frequency we have 3, 12, 18, 12 again, and 3. So the total is 48. Okay, that is given. So first, let us take any of the numbers. Let us take 12 because this is the midpoint. So we are taking assumed mean. So we are taking assumed mean A is equal to 12. So from here, we create the first table, the first column here, and the column is D equal to X minus 12. Then we will find D square, then we will find FD, and finally we will find FD square. Okay, so since we have frequency, we will have to create more number of tables, FD and FD square. So let us first try to do this. D is equal to X minus 12. Please remember, we shall consider the sign here. Plus sign or minus sign will be considered because it is not the modulus value. We have to take both the signs. So here we get 10 minus 12, so minus 2, 10 minus 12, 11 minus 2, 12 is minus 1, 0, 1, and 2. Now this, if we see, what we will get is we have got D square here. Okay, so let us take D square. So, but then before that, let us take, we will take FD also. Okay, so first let us do D square minus 2 square is 4, minus 1 becomes 1, 0 square is 0, 1 square is 1, 2 square is 4. So this gives us basically the D square part. Okay, now we have to find FD. So FD, when we check, FD is minus 2 into 3, that is minus 6. 12 into minus 1, that is minus 12. 18 into 0, that is 0. 12 into 1, 12. And 3 into 2 is 6. So FD becomes 12, 0. So it's all nullified, it's 0. So you can see minus 6, minus 12, that is minus 18. Plus 12 and plus 6, that is 0. FD square, let us try to find FD square. D square we have got 4, and F is how much we have? D square is 4, and we can see F is 3. So 3 into 4, that is 12. 12 into 1, we are getting 12 again. 18 into 0 is 0. 12 into 12. So frequency is 12 and frequency is F is 12, and we can see D is 1, sorry. So 12 into 1, that is, we are getting FD square. So D square is 1 and 12, so it is 12 again. And 3 into 2 square, D square is 4 and this is 3. So we get 12. So we have 1, 12, 2, 12, 3, 12, 4, so 48. So we have completed the working. Now we have to find the standard deviation. Standard deviation formula is sigma small sign sigma. This is equal to how much? So we will take sigma fd square by n minus sigma fd by n whole square. So fd square by n gives us 48 divided by n. N is how much? N is also 48. It is given. Total frequency is 48. So 48 by 48 minus sigma fd by n. Sigma fd is 0. So it is 0. So we are getting ultimately 48 by 48. That is 1. Square root of 1. That is 1. Answer is 1. Okay. So in this way we are doing it. Yes. SD is 1. Bhumika, Komalakshmi. Yes. Very good. You have got 1. So this is a type of problem which you may expect. So it is just, you can see it's 4 tables. We are constructing 4 tables. If you see, this is given. These 2 tables are given. So first we are constructing D, that is the deviation. Then we are constructing D square. Then the third column we are writing is FD. And the fourth column is FD square. So we are dealing with 4 columns, right? And then we are able to use the formula sigma fd square divided by n minus sigma fd divided by n whole square. Okay, so that is basically what we are doing. So these 2 problems are very, very important problems for your understanding, and also these are not very difficult problems. We can just solve it using 4 simple columns, and the formula now I'm sure is clear to you. We will proceed further, and now let us take another example. This time you can see formula. We have to use the same formula. The distribution is given. Here we are having different values of x, and we are having the frequencies which are given. So let us try to do this. Okay. Let me see. Ankit is asking, please repeat which part? FD. Okay. FD. Ankit, please note, FD is what? F into D, frequency into D. So 3 into minus 2 is minus 6. 12 into minus 1 is minus 12. 18 into 0 is 0. 12 into 1 is plus 12. And again, you have 3 into 2 is 6. So sigma FD, minus 6 minus 12, that is minus 18 plus 12 and plus 6, that gives you 0. So sigma FD is equal to 0. In this case, of course. So here you can see this is FD. D is what? The deviation calculated by subtracting the assumed mean from each of the numbers, right? So we have just done F and D multiplied by F and D, we are getting FD. So sigma FD is here 0. In this case, it is 0. So the formula which we have drawn, once again, I'm writing, then it will be, Ankit, I hope you are following, and you can get the clarity. So sigma is equal to summation fd square by n minus sigma fd by n whole square. Okay, so this is the formula. So you can say here I have written n. N means sigma f is actually n. The total frequency is n. So here it is sigma fd square. We have done f and d square multiplication by n minus what we have done, sigma fd, f into d multiplication, f into d. That is the total amount is sigma fd by n whole square. This part we are squaring. Okay, fine. Okay. Okay, now let us take the next question and try what will be the way to solve it. What will be the answer? Let us check on the process. So here let us take any of them as the assumed mean. So we can take any of them. Let us take 34.5 as the assumed mean and see what we get out of it. So x is given, f is given, 4.5 till 64.5. So we are doing a longer problem now. 4.5, 14.5, 24.5, 34.5, 44.5, 54.5, and 64.5. So we have 1, 2, 3, 4, 5, 6, 7. 7 observations. So we will take the middlemost observation as the assumed mean. So let us take 1, 2, 3. So 34.5. So assume mean equal to 34.5. Step number 1. Frequencies we will note down 2, 3, 5. 2, 3, and 5. We will copy the frequencies 17, 12, 7, and 4. Fine. Let us find out the total frequency. 2 plus 3 is 5 and 5 is 10. 10 and 17 is 27. 27 and 12 is 39. 39 and 11, that is 50. So we are getting sigma f is equal to 50. So these 2 points we have noted. Sigma f equal to 50. That is total frequency is 50, and we have noted that the assumed mean is taken as 34.5. Now let us try and find out what will be. We will try to find out what will be the. Let us take deviation d. Okay. So for the deviation d, let us take here. We will take d, that is x minus assumed mean. So 4.5 and 34.5. So it becomes minus 30. So we are taking minus 30 here. 14.5 minus 34.5, this becomes minus 20. 24.5 minus 34.5 minus 10. 34.5, this becomes 0. 44.5 is 10. 54.5 is 20. 64.5 is 30. Fine. So D is done. Okay. Now here we can also use the class interval. So it is here, we can see it is basically 10 each. Yes. Yes, Shiva, thank you. F is 50. Yes. Right. Now let us just try it out and see. So D we know, D we have got, that is the difference of each of the numbers from the assumed mean. Now we will take D dash, which is, you can do it like this. D dash means the deviation divided by the class interval. So we can do it. We may not do it. If we do this, then we have to multiply standard deviation figure. We have to multiply by the class interval. So let us try it out and see both the methods. So D dash is equal to D by 10. So now it becomes minus 30 by 10. Why we are taking 10? Because 4.5 to 14.5, this is one class. So it is 10. 14.5 to 24.5. See the gap, everywhere the gap is 10. The gap is 10. So we are taking 10 as the class width. And therefore we are getting minus 3, minus 2, minus 1, 0, 1, 2, and 3. So we have got D dash. Now we will find FD dash. FD dash, and last one is FD dash square. So FD dash, that is frequency is 2 and D dash is minus 3. So minus 3 into 2 is minus 6. Minus 2 into 3 is also minus 6. Minus 1 into 5 gives us minus 5. 0 and 17 is 0. 12 into 1 is 12. 7 into 2 is 14, and 4 into 3 is 12. So we are getting FD dash. This is equal to 12 and 14, that is 24 plus 14, 38. So we have 38 here, and in the negative side we have 17. So we are getting 21. Sigma FD dash is 21. Sigma FD dash is 21. Now the last column we are working, and that is to find out the square. Okay, we are trying to find the square. D square, that is D dash square. D dash square is basically what? D dash square will be 3 3s are 9. 9 into 2, so it is 18. Minus 2 into minus 2, that is 4 into 3, that is 12. 1 minus 1 into minus 1, that is plus 1 into 5, that is 5. 0 remains as 0. Then we have, we can find out D dash is 1 here. So 1 into 1, that gives you 1. And this into 12, that is 12. And then we have 2, 2 2s are 4, 4 7s are 28. And the last one is 3 here. 3 3s are 9. 9 into 4 is 36. So now we will try to get the total here. 18 and 12 is 30. 30 and 5 is 35. 35 and 12 is 47. 47 and 28. 47, 28, 75 and 36. 111. I am getting 1, 1, 1. 75 and 36. So from this, we will calculate the standard deviation. We have finished doing the calculation. We just need to put together the formula. So the formula, I'm just rubbing this side, partly, just try to write it here. Okay, just writing it here. So the formula, therefore, will be sigma fd dash square by sigma f. In this case, we have taken the class width. So 111 divided by 50 minus, okay, minus sigma fd dash. Sigma fd dash is 21. 21 by 50, this square. Whatever value we get, we will multiply that by the class interval I, that is 10. Why we are multiplying? Because we had divided here by 10. See, each of this, minus 20 has become minus 2, minus 10 has become minus 1, 10 has become 1. So in this step, we had divided by 10. So now we will multiply. And if we work it out, so we have got 111 by 50 minus 21 by 50 square. So if we work it out, as per the slide, you can see the standard deviation will work out to 14.295. 14.295. Okay, there is one question from Jana Lakshmi, why we are using D dash. We are using D dash. In this case, this is one way to solve it, because you can see we had divided the deviation by the class width. That is why we have used D dash here, because it is D by 10. Since we had divided by 10, that is why at the last step, we will multiply by this 10. Whatever value we get in the standard deviation here, we will multiply that by 10 so that we arrive at the right standard deviation figure. Okay. Right. So in this way, we solve this. You can, if you want, you may not go for D dash also, you can directly try it out. Okay. So let's see if there is any variation, and if so, what will be the variation if we do not take D dash? Okay, so let's do from here once again, and let's see what will be the impact if we do not take D dash, and whether we arrive at the same number or not. Okay, so this time we are trying to do some experimentation. We are not going to take D dash and see what is the impact. So F is given, we directly go to D. So D is assumed mean was, we have taken 34.5. So this becomes minus, but you see here we have to, we'll get some bigger numbers. So we are getting here minus 30, minus 20, then minus 10. Okay, 0, 1, 2, and 3. 10, 20, and 30. Okay. So this is what we have got. Instead of going for D dash, let us see if we can directly go into FD and FD square. Now, the point is it will become bigger, as you can see. If D is this, then D square becomes 900, 20 becomes 400, 10 becomes 100, again 100, 200, and 400. Sorry, this is 900. 20 becomes 400, 30 becomes 900. D dash becomes quite big. FD, let us try FD. 2 into D minus 60, 2 into minus 30. 3 into minus 20, again minus 60. 5 into minus 10, minus 50. 17 into 0 is 0. 12 into 10 is 120. 7 into 20 is 140. 4 into 30 is 120. So you can see we are now dealing with much bigger numbers. That is the reason why we had divided by 10. And so we got this column, which you can see here, D dash column. So we are dealing with bigger numbers in this case. And finally, we have FD square. So here D square is how much? D square is 900. So 900 into 2, 1800. 400 into 3, 1200. 100, 400 into 3 is 1200. 100 into 5, 500. This 100 into 12 is 1200. This becomes 0 again. This 400 into 7 is 2800. 900 into 4 is 3600. So we are dealing with bigger numbers. So if we add it up, what do we get? 1800. So 18 and 12 is 3000, 3500, 4700. And we get the same. Okay, 4700. So plus 2800, that means 575 and 36, 11100. Same, we get the same. So here again, FD dash, we can calculate So 120, this 60, 60 and 120 goes out. So we have 260 and 260 minus 50, 210. So this is also possible. You may not go for division. Now, therefore, the final formula, we are using the old formula, the first formula. So sigma is equal to square root of sigma FD square, 11100 by 50 minus 210 by 50, and this is the square. So we get this almost the same format, and the same only point is we don't multiply by 10 here. So if I just get it, if I simplify it, we get 500. So 11100. So here we will get 1110 by 5. So it is 222, I think. Yes. Minus 210. So 21 by 5, that gives you 21 by 5. That's just you have to calculate 21 by 5, and you have to find the square. So 21 into 21, so 25 here. 21 I think is 441. 21, 22 is 44, 146, 22. Yeah, 441. So 222 minus 441 by 25, you will get the same answer, which we have got here, square root. So ultimately, whichever formula we use, ultimately we get the same standard deviation. The only point is here, the calculation, as I've just done, becomes longer because we have not divided by the class interval. So the numbers are bigger. The numbers are bigger, so it takes more time to calculate. Otherwise, if you divide it by 10, which is the class interval in this case, then the numbers become smaller, so more manageable to handle in the exam, right? So we will get the same. Yes, many of you have got it. Just breathe. Yes, the same. We will get the whichever path you use, both the formula are applicable and valid. So whichever path you use, we will arrive at the same answer. There is no variation between the two methods when it comes to the final answer. Good. Same answer. Many of you have got it. Now we will take the next point. So we have tried all possible types of questions for the exam. One type of question is where we don't have any type of frequency, and the other type is a frequency, like we have handled this question. Now let us take the last category where we have grouped distribution. This is the toughest type of question which can be expected from this chapter, of course, as per our curriculum in foundation. So here we have the last category. So this is the complicated, most complicated, if you call it at all complicated. It's the most looking, the problem looks bigger, and but we will simplify it and we will solve it in steps. So standard deviation is given. Typically what we get is a continuous standard deviation. You can see the distribution is absolutely continuous. So 44 to 46, 46 to 48. So it is absolutely continuous. It's not a discrete, it's continuous. So the class boundaries are given. So we will just try to find the midpoint. We will try to find the midpoint of the class. Each of the class, we will try to find the midpoint, and then we will proceed as per our original technique which we follow. Okay. Ankit, just follow this one, then you will understand. We will do more problems from the exercise also, but just follow this particular problem, you will understand the entire working once again. Okay. So let us try and see what we are getting if we simplify this problem. First, we write down the problem. So 44 to 46, 46 to 48. Please note that the interval is 2. 48 to 50, then 50 to 52, 52 to 54. This is the class intervals which are given. This is in kg. That means the standard deviation also will be in kgs. Number of persons, that is frequency, is given 3, 24, 27. 3, 24 and 27. 21 and 5. The total is given as 80. Okay. Step number 1, we find midpoint. Okay, here we have to find the midpoint. So I'm writing MP, midpoint. 44 and 46, midpoint is 45. 46 and 48, midpoint is 47. 48 and 50, it is 49. Just a moment, it is 49. So midpoint of 48 and 50, we are taking as 49. 50 to 52, it is 51. 50 to 54, it is 53. So midpoint is done. Out of this, let us take 49 as the assumed mean. So I'm writing here A is equal to 49. So the deviation will be x minus 49. X minus 49. D. So we are creating the next column D. Yes, n is 80. Yes, Komalakshmi. Yes, n is 80. Now we are trying to get x minus 49. 45 minus 49, that gives us minus 4. 47 minus 49 minus 2. 49 minus 49, 0. 51 minus 49 is 2. 53 minus 49 is 4. So D we have got. Okay, D we have got. Now we will try to get FD. Okay, first let us take D square. We can do it in one step. 4 and 4, 16. 2 into 4, 2 into 2 is 4. 0 into 0 is 0. 2 into 2 is 4. 4 into 4 is 16. So D square we have got. But we have to find FD, and now we will find FD square. FD and FD square. FD we are finding. FD. So F is this column is F, and D is here. So 3 into minus 4, minus 12. Be very, very careful. Please be very careful with the sign. That is the positive sign or the negative sign. Okay. D is minus 2 and F is 24. So it gives us minus 48. 0 here. So it is 0. 2 here and frequency is 21. So it's 42. 4 here and frequency is 5. 4 into 5 is 20. So we are trying to get minus FD. Now we are calculating FD square. So D square we know 16 into F, because we are finding FD square. 16 into F. 3 for the frequency is 3. 16 into 3 is 48. Now we have 4 here. 4 and the frequency is 24. So 24 into 4 is 96. 0 and 27, 0, no problem. Then D squared 4 and here we have 21. So it is 84. 21 into 4 is 84. And here we have 16 and here we have 5. 16 to 5 is 80. So we have got the calculations. Now it's only we need to add up. So on this side we have 48 and 12, that is 60 minus 60. On the positive side we have 62, I think. 62. So we are getting plus 2 here. Total sigma FD is coming to 2. And FD squared, let me just work out and check. So 96 and 48. 96, 48. So it comes to 14, 144, 144 and 164. So this is 8, 0, 308. Just try it on 308 I'm getting. Okay, I will check with the problem if we have gone wrong anywhere. So it is getting. Okay, Vinita is asking, why don't we take n as 5? Okay, why don't we take n as 5? Now please note that here we have frequencies. Okay, if there is no frequency, you will take n as 5. But if there are frequencies, that means what? 45, there are 3 people. 47, 24 people have got. 49, 27 people have got. So ultimately we have to take the frequency n is equal to sigma f. If no frequency, if there is no column, then it will be 5. Okay, so I hope you have understood this. This came from Vinita Sharma. This question: why don't we take n as 5? Okay, so I hope Vinita you understood that if there is no frequency, like if I go back once, I'll go back to the slide. The first problem which we did here, you see there is no frequency. Please see this problem: 7, 9, 16, 24, 26. There are no frequency. So please note the number n is equal to 5. See, 82 divided by 5. But the moment we have frequencies, we have to take frequency sigma f is equal to n. Okay, right. Some people have already got the answer. I'm just trying to solve it out. So here, therefore, we have got these numbers here. And if you just find out the formula, The formula, therefore, sigma, that is standard deviation, will be equal to, I'm getting 308 sigma FD square, 308 divided by 80 minus 2, that is sigma FD by 80 square. Okay, so this should get, this should give us the answer. We'll just check whether we have done it correctly. Okay, right. So we will get 300 by 80. Let us just calculate and check what we are getting. 308, yes, Ankit has written 308. 308 by 80, just let us try it out and see what we are getting. 308 divided by 80, we are getting 3.85. So we are getting 3.85 minus 1 by 40 square. Okay, so 1 by 40 square, that means 1 divided by 1600, 40 square for 40, yeah, 1600. So we are getting 0.000625, 0.000625 minus 3.85. Let us just try it out and see. 3.849375. Okay, 3.849375. So we have to find square root of 3.849375. So just find out the square root, and I think it should come to 1.96. Okay, because we have done whichever formula we do, ultimately the answer will be the same. In one case, we are actually dividing it by the class interval. In some cases, we may not. Here, of course, if you divide by class interval, the numbers become small. Here, the numbers are bigger because I have not taken the class interval. Okay, so that's it about standard deviation. We are now going to go into the next discussion. Before that, just we have a important point, and that is there is one formula we have to check, and that is what happens if there are two groups, N1 and N2, two observations, two groups, one having N1 observations, the other one is N2. So what happens if the first group has standard deviation sigma 1 and the second group has standard deviation sigma 2? So we have two groups here. First is group with N1 observation and group 2 with N2 observation. So we have two groups, N1 and their standard deviation is sigma 1. The second group has N2 observation and their standard deviation is sigma 2. So how to combine? We will do that. Before that, just a quick look at the properties. Please note that this is a very important property for your exams. SD remains unaffected due to a change of origin, but is affected in the same ratio due to a change in scale. So therefore, in case you get a particular problem, y equal to a plus bx, if you know that the standard deviation of x, say, is sigma x, then you can find standard deviation of y. Sigma y will be equal to b into sigma x. Okay, so it is modulus b into sigma x. This is a very important relation which you need to remember for solving problems, and quite a number of problems are coming on this formula. Very, very important formula. Okay. Now, if all the observations assumed by a variable are constant, then the SD is 0. As simple as that. Why? Because there is ultimately the deviations will be 0, and therefore the square of the deviations also becomes 0, and therefore the SD, ultimately the SD becomes, there is no component as such, and therefore you get 0. Okay. Now we come to combined standard deviation. So this formula is, you have to note this formula. We can calculate combined standard deviation N1 and N2. So for two groups which have standard deviation sigma 1 and sigma 2. So first of all, please note that here the combined standard deviation will be given by sigma 1 2. Sigma 1 2. Okay, and the combined standard deviation, let us just note down the standard deviation combined. So we have two groups, N1 and N2. First group has standard deviation sigma 1, and the second group has standard deviation sigma 2. Okay. There's one question, Dhyanesh, can SD be negative? No, SD cannot be negative. We will always take the positive square root of the expression which is given. Now we look at the formula sigma 1 2, that is the combined. I'm writing the word combined. Combined SD. Combined SD is given by, this is a, this has to be remembered, this formula, because questions can come based on this. One question I will solve, which is absolutely important for the exam, and it is based on this particular formula. So what we do is n1 sigma 1 square plus n2 sigma 2 square plus n1 d1 square, d1 square plus n2 d2 square divided by n1 plus n2, that is the total number of observations. Here d1, if you see, means d1 is equal to, and d2 we have to know, d1 is equal to x1. That is, in our example we have taken the number of observations, x1 bar minus x12 bar. So for the first group, so we were assuming that there are, say for example, x1 items. So x1 bar minus x12 bar. Similarly, d2 is equal to x2 bar minus x12 bar. So mean of the combined, and x12 is what? X12 is the combined mean, and that is given by n1 x1 bar plus n2 x2 bar divided by n1 plus n2. So this is a very, very important formula. Okay. Dhara is asking, is variance there in the curriculum? Yes, Dhara, it is there. We will calculate variance. It is just variance square of the standard deviation. We will take one problem based on variance, because variance is the square. Okay. There is one question from Manisha. I am unable to find previous year's question paper of BMLRS. Well, for the previous year's question, I think it should be available online, and you may also get the hard copy of the question available. So you may go through that. And number two is, please note the mock test paper of the last few terms are given in the website ICAI.org. Please also download the mock test paper. And previous question should be available online. Just search, make a thorough search, you will get it definitely. Okay. So here we will do one question. This is very, very important for the exam. I have written on the slide important example. So two samples of size 40 and 50 have the same mean 53, but different standard deviation. Now this can be possible. They have the same mean, but different standard deviation. So we are taking two samples. There are 40, that is 40, and there are two samples. So we can write n1 equal to 40 and n2 equal to 50 here. And they have the same mean. So x1 bar equal to 53, and they have the same mean. So x2 bar is also equal to 53. But different standard deviation. They have 19 and 8. So standard deviation sigma 1 is 19 and sigma 2 is 8. So we have got quite a number of figures now. So we have two groups, 40 members in first group, 50 members in second group. The average of the first group is 53. The average of the second group is also 53. The standard deviation of the first group is 19, and the standard deviation of the second group is 8. So first and foremost, we have to find out the deviations, that is D1 and D2. Now D1, if you see, D1 basically was x1 bar minus combined mean. Okay, now we have to find the combined mean, x12. x12 bar we can find out from the formula which is given, that is x12 bar is equal to n1 x1 bar plus n2 x2 bar plus n1 plus n2. This is equal to n1. N1 is 40. 40 into 53. 40 into 53 plus n2 is 50. 50 into 53. Both have the mean 53. Divided by 40 plus 50. 40 plus 50. So here we are getting 40 into 53 plus 15 to 53. So if you take 53 common, you have 40 plus 50. In the denominator also you have 40 plus 50. So it becomes mean is 53. Mean we have got is 53. So D1 bar, D1 dash, okay, D1 is equal to x1 bar minus x12 bar. x1 bar is 53. And now x12 bar, which we have found out here, x12 bar is also 53. So it becomes 0. D2 is equal to x2 bar minus x12 bar. X2 bar, if you see, is 53. X12 bar, if you see, is also 53 because we have worked it out here. So again, it becomes 53 minus 53, which is 0. Okay, so D1 is 0, D2 is 0. Now, therefore, we put the final calculations. So we have got all the figures. I will write here x12 bar is also equal to 53. D1 is 0, D2 is 0. Fine. So I'll rub this part and let us write the final formula for calculating the standard deviation. That is the combined. We are doing the combined standard deviation. Sigma 1, 2. Okay, sigma 1, 2, that is the combined standard deviation. So this is equal to n1 sigma 1 square. So 40, n1 is 40 into sigma 1 square, 19 square, plus n2, that is 50 into sigma 2 square. Sigma 2 is 8, so 8 square. But then do we have D1? There is nothing called D1. D1 is 0 in this case. D2 is also 0 in this case. Therefore, plus 0 plus 0. Divide it by n1 plus n2. N1, that is 40, just writing 40 plus 50. So we have got 40 into 19 square plus 50 into 8 square divided by 40 plus 50. On expanding and simplifying, you should be getting the answer, which is also given in the slide. You are getting the answer is 14. Okay, SD is 14. Yes. Jyoti, I will check. Previous years is not available in the site. We will check that once again, but it should be available if you just search it online in your in the internet. I'm sure you might get it in some other websites. It could be there. Just check. Okay, previous year's questions. Okay. You can also get a hard copy. I think hard copy should be available. Just try and you'll get it. Okay. If I get any other website or if I get it in the past, if I get the past questions, I will try to definitely I will upload it in the portal. Okay. Now we have completed the SD part, and now variance. So the square of the standard deviation is called variance. So variance is nothing but we can write variance, sometimes written as VAR in short. So variance is nothing but the square of the standard deviation. So we can write sigma square is equal to variance. Sigma square. Sigma is standard deviation. So standard deviation square of standard deviation will give you variance. Now a very important formula. Okay, we will go through it. Ankit, can you just see, just once again, let us go to the last slide. Please see the working out here. So N1 40, you know, N2 is 50. Now both the mean are same. Please note that X1 bar and X2 bar both are 53. So if you use the formula, you will get the combined mean is also 53. That is X12 bar is also 53. If that be the case, then you can see D1 and D2, the value of D1 and D2 both will work out to 0 because D1 is X1 bar minus X12 bar. Okay, that is the mean of the first group minus the combined mean. First group is 53, it is given. Combined mean is also 53, so D1 becomes 0. Similarly, D2, which is the second mean of the second group minus combined mean, that is also arriving at 0. So ultimately, if you look at the formula, if I go back one step, you can see N1 X1 bar plus N2 X2 bar divided by N1 plus N2. This is the formula for the combined mean. We have got it. Now we put all this value here, N1 sigma 1 square. N1 is, I think you have seen 40. 40 into sigma 1 square, 40 into 19 square, because sigma 1 is 19. Sigma 2 is 8. So N2 is 50, sigma 2 is 8. So you get 50 into 8 square. But then this D1 and D2, which you see both as 0. So this N1 D1 square becomes 0, N2 D2 square also becomes 0. So ultimately you are left with what? You are only left with N1 sigma 1 square plus N2 sigma 2 square. Divide that by N1 plus N2. Okay. So I hope it is now clear. You can now calculate, just try it out once again, the last part, and revise what you have done, and you will get 40 into 19 square plus 50 into 8 square divided by 40 plus 50. And then the remaining is just simplification. Okay. Right. Okay, Manisha, you have said, okay, let me just find out if we can get the past year's question. MTP you have got? Okay, MTP, we will go through the MTPs also. It's very, very useful. And see if you have any friends who have appeared for the exam, definitely they will be able to tell you about the past year's questions. Sometimes you may get, I think the hard copy, sometimes you get there's a hard copy book also which comes out with the past year's questions. You can just have a look. If you get that, it is good enough. Okay. Now we go to coefficient of variation. Coefficient of variation is a very simple formula, SD by mean into 100. So it is the ratio of the standard deviation and it is divided by the mean. It is expressed as a percentage because we multiply it by 100. So actually this is also one of the developments, of coming from Professor Carl Pearson. So he was the first to give us this particular measure to measure the variability. So SD by mean. And here again, the coefficient of variation, that is CV in short, coefficient of variation is equal to sigma by mu. So sigma by mu into 100, where mu is the mean, or we can write it as SD by mean into 100. This is the coefficient of variation. Okay, also known as coefficient of variability, and it is expressed in out of 100. So therefore, you can say we are multiplying it by 100. So it is like a percentage. Okay. So the coefficient of variation, and okay, thank you, Ankit. Okay. Coefficient of variation is a relative measure of variability that indicates the size of the standard deviation. So how big the standard deviation is compared to the mean. So bigger the CV, that is bigger the coefficient of variance, more will be the variability. So it is a standardized measurement and it's unitless because you can see that say the SD is in kg, or and mean is also in kg, therefore so kg and kg will cancel out. So coefficient of variation, CV, coefficient of variation, will be unitless. There will be no unit. Okay, so it is just an absolute number or a percentage, you can say. Now please note it is known as relative standard deviation or RSD, and definitely it is a very good measure for comparison of two distributions or two groups of data. Where we cannot use absolute measures, we will definitely try to use the coefficient of variation. Okay. Now variance. Okay, I think one of our friend was asking about variance. Okay. Variance is a measure of how data points differ from the mean. We have already discussed it. Variance or dispersion means scatteredness. So a variance is a measure of how far a set of data are spread out from the mean value. I hope it is now simple to understand. In standard deviation also, we have calculated that if A is the assumed mean, we have tried to find out the deviations. More the value of variance, definitely the data is more scattered from the mean. It is not a good measure. Like we took the example in the last session that if we find that the number of students, say there are 5 students in a class, and you find that their marks in a particular paper are close to each other. On the other hand, in another group, you find the extreme marks. Some have got 85, 90, some have got 45 or 48. So that shows extreme. In that case, in the second example, the standard deviation will be more. The variance is more. The variability is more, and the data are more scattered. Okay, so that is not a good, it's not a good distribution. Similarly, when we took the example of share market and the share price. So, or if you think of a dividend which a company pays, if it goes up and down, a lot of variability, well, people will not like it. But people would look forward to those type. I'm saying those people who are investors. I'm not talking about speculators. Speculators may be interested in high jumps and again low falls, high falls. But then when we look at investment from a long-term perspective, definitely people want steady. I'm using the word steady. Steady returns means it will not fluctuate. It will not be dispersed. It will be more or less stable and straight. Okay, so that is the reason why we have the measure of dispersion, and variance is equal to standard deviation square. So it is measuring the spread of data from the mean. Just one simple example. The formula therefore is x minus mu, the deviation. So deviation square gives you the basic formula variance. And variance is the square of the standard deviation that we have already stated. Now we will look at variance. I was writing also, variance is a sigma square. So var, as we call it, is equal to sigma square. Okay. One example of variance, find the variance of the numbers 3, 8, 6, 10, and so on. So the numbers are given. So we just mean a calculation has to be carried out. First, we can find out the mean of the 10 values which are given. The mean comes out to 8.8, and then you can find out there are 10 numbers, and you can see the mean comes out to 8.8. So now again, the same way, for each of the values which are given, we find out x minus mu, and here we get x minus mu. Sigma is the total number. You can see the total amount comes to 73.6. Sigma deviation square is 73.6. We divide that by the number of observations. Since we don't have frequency here, we are taking the total number of observations which are there, which is 10. So 73.6 by 10, that is 7.36. Okay. So this is, you can see we have written coefficient of variation here, sigma by mu into 100. So let us take a simple example, and we will try to find out coefficient of variation. We will take some examples. Okay. Before going to the last part, which is quartile deviation. So if it is given that, say, I'm just taking randomly two observations, 40 and 50. Okay. Now let us take the last case. Sigma 1 is given. Sigma 1 is how much? It was 19, and sigma 2 is 8. Mean, that is mu 1 is 53. Mu 2, let us take is let us take as 40. Okay, let us take as 40. So we have to find the coefficient of variation, and we have to compare what is the CV. Coefficient of variation, that is CV1, that is for first group, is 19 by 53. 19 by 53 into 100. 19 by 53 into 100. Let's just work it out and see how much we are getting. 19 divided by 53 into 100. So 36, around 36%. Around 36%. Okay. In the second case, we are getting CV2 is equal to 8 by 40 into 100. So we are getting 2 by 5. Wait, sorry, 81 by 5, that is 20%. We are getting 20%. So we can say that in the second example, we can say that out of these two cases, second example has lesser variability. The first one has higher variability, right? So we took the SD, and we have taken the mean also, mean. So three numbers. Here we are basically dealing with these two, sigma 1 and mu 1. Here we are dealing with sigma 2 and mu 2. So this is how we calculate the coefficient of variation. Okay. From Bhumika, a question has come. Mu will be in question, or we have to find that? No, mu will be given in the question. In standard deviation, in coefficient of variation calculation, in most of the cases, mu will be given. Okay. Now, the advantages of standard deviation is it is based on all observations. As we saw, you have to take all the observations, because when we are calculating the deviation, we are actually taking all the observations. It is not like median, where we are only thinking of the middlemost observations. Plus, you can see we could see a lot of mathematical properties, and it is definitely, it can be used in an algebraic way. Algebraic treatment can be carried out. For example, when you have two groups, N1, N2, and you have mu, say sigma 1 and sigma 2, which is the standard deviation of these two groups, you can find out the combined standard deviation. So there is an algebraic treatment which can be carried out. Also, it is less affected by sampling fluctuations as with most of the measures of standard dispersion. Coefficient of variation is the most popular and most appropriate, which is a relation between standard deviation divided by mean into 100. Yes, like other measures of central tendency and dispersion, everything has a disadvantage here again. So it is not easy to understand. Yes, sometimes now it might be easier for you, but compared to some principles like range is the most easy to understand, highest value minus lowest value. But SD, sometimes it is a bit confusing to understand. Uses of standard deviation is vast, no question. Best measure. Wherever possible, we use it. So when we find out, like in an exam, when we carry out a standard deviation calculation, we can get the variability of the scores. Which class or which group of students have the most uniform scoring, that can be done. Similarly, in the investment, finance, corporate finance, we can use standard deviation to understand what is the degree of variability of the returns of a company. Say a company is having up and down returns. That means their net profit is going up and down. So from these values, we can find out the standard deviation. That company which has lesser standard deviation of the returns means the risk is less. Later on, you will find in risk management, once you study risk management later on in CA, you will find that risk is measured absolutely by standard deviation. Variance is the way to measure risk. So there again, you will find the same formula. Sometimes in CA final, little bit of it you will also learn in IPCC. Okay, in your financial management paper. So it's a very practical concept, no doubt about it. And it is used in a wide variety of formulas in finance, in economics. And without the understanding of variability and standard deviation, we cannot come to the conclusion about the nature and the performance of any type of mathematical model, right? So that is very, very important. Good. Yes, some of you got it. Like Jaspreet, Shiba, Bhumika. Yes, you've got it. Yes. Now we go to the last part for today, the last part of this chapter on dispersion, that is interquartile range. It is a very simple formula. We have completed the most difficult part, that is standard deviation, including the formula for the combined standard deviation. Now this is interquartile range, that is quartile deviation. So quartile deviation, you know, is we had already covered Q1, Q3. We discussed about the quartile deviation. So we will easily understand the concept of interquartile range. Q3 minus Q1 gives you the interquartile range, basically. Now, Q3, we know how to calculate. We have covered that in our discussion on measures of central tendency. So please remember that this formula we will use, Q3 minus Q1. This is the formula we will use, and let us see an example, then we will understand. So quartile deviation is the product of half of the difference. You can see it is half of the difference between the upper and lower quartiles. So QD, we ultimately are dealing with Q3 minus Q1. And mathematically, we say it is half, product of half of the difference. So we add half divided by 2, Q3 minus Q1 by 2. Now the quartile deviation defines the absolute measure of dispersion. How do we find quartile deviation? Quartile deviation coefficient, if you talk about the coefficient, relative measure. Okay, so when we talk about the absolute measure, we get the QD. When we find out the coefficient of quartile deviation, that is equal to Q3 minus Q1 divided by Q3 plus Q1. That gives us the, or you can multiply it also by 100. So we get the coefficient of quartile deviation. Okay, so this is a very, very simple, much easier to understand concept than then of course standard deviation. Okay, Manisha is asking, there's one question, what kind of theory in statistics can be asked? Manisha, and to all of you, kindly note that the properties, now we have done central tendency. Now you see we started first with data, representation of data, charts and diagrams. So please be very careful about your knowledge about the basics of statistics. What is data, for example? The different types of data, continuous data, for example, right? Discrete. Then we discussed about the different ways in which data can be presented. bar diagram, say for example, histogram, ogive, frequency distribution, frequency polygon, cumulative frequency. So all these basic understanding you must have. So please go through the session, the videos once again. Please kindly go through the study material once again, so that your knowledge, you have to revise. You have to see you are learning so many chapters one by one. So you have to periodically revise so that you remember the key points, right? Second is from the theory, say in central tendency. Now you have so many formulas also. Now you can get a formula. For example, a very simple one is mean minus mode equal to 3 into mean minus median. So this is theory, this is formula. I'm not giving a problem on this, but you may get a question like this: which relation links up mean, median, and mode? And they may give you 4 alternatives based on the formula. So this type of questions are very important. Similarly, which type of central tendency measure is most appropriate? This type of questions can come as a theory question. In the chapter which we are just covering today, we are completing, that is measures of dispersion, we have discussed in detail about the types of dispersion measures like range, and we had covered mean deviation, standard deviation. So please be very clear about the properties, the formula which is used, and number 3 is the advantages and disadvantages. That is why I am covering all the theory part also. I'm not only working out the problems, but also covering the theory, because you never know, a question on theory might come. Okay, and it has happened in the, if you look at the questions in the mock test paper, which is already there in the website, you will find quite a number of theory questions are there. So you might get, theory questions from any of these chapters which we have covered so far. So please be clear and please revise so that you have a solid understanding about the formula, properties, disadvantages, the advantages, and the disadvantages. So these are the points or the source from where theory questions could be coming. Okay. Right. Now we go into the properties of QD, and then we will see 1 or 2 questions. Quartile deviation is the best measure of dispersion. Please note, for open-end classification. Why? Because for open-end classes, if you don't have the ceiling, if you don't have the upper class boundary, in spite of that, you can carry out quartile deviation calculation. Why? Because quartile deviation does not deal with all the observations. It basically deals with the middle. Okay, so even in case of open-end classification, we can use it. It is less affected by sampling fluctuations, very similar to what we have in standard deviation. And it is, when it comes to that important question, that if you have the relation like y equal to a plus bx, okay, please remember the formula is very simple. If y equal to a plus bx, and if it is given, please note, if it is given that the quartile deviation of x, q dx, is, say for example, let me take a simple example here. Let me write a particular equation. So I'm writing 3y is equal to, let me write, say, let 3y equal to 2x plus 9. 3y is equal to 2x plus 9. It is given that the quartile deviation of x is, say, let us take 7. You have to find the quartile deviation of y. So quartile deviation of y is to be, we don't know, question mark. So how to handle this problem? So these type of questions, very, very common and often coming in the exams. And these are absolutely simple to solve questions. You don't have to go for a table or not much of calculation. So what we do first, from this equation, we write it in the form of y equal to a plus bx. Okay. So we know y equal to a plus bx. So this becomes 3y. So this will become 3y. If I just take y here, so how will it look like? Y equal to 2 by 3. 2 by 3x plus 9 by 3, that is 3. So now it is basically y equal to a plus bx, where b is 2 by 3. 2 by 3. So in this type of problem, we have to use the formula q dy is equal to mod b into the quartile deviation of x. B is 2 by 3. So 2 by 3 we know, into I have taken QD of X is 7. So 2 by 3 into 7, that is 14 by 3. Is almost equal to 5, say 4.99 approximately. Okay, so this is how we find out the quartile deviation. Very important question, and these type of questions are coming. These types are very, very relevant and possible to come in the exams. Okay. So let us take this question from the study material of our institute and try to solve it out. Following are the marks of the 10 students. We have to find QD and the coefficient of QD. So if you look at the question which is given, there are 10 students. We have to find the quartile deviation. 10 students are there. Okay. Now we know quartile deviation is, we have to first arrange in ascending order. Why? Because we have quartile is something which is we have studied when we were analyzing, we were understanding median. Okay. So it's a measure of quartile deviation means ultimately quartile as such is included in the measure of central tendency. So we write it in the ascending order, and we get say the number, the marks will be like this: 35, 42, 48, 50, 48, 50, 55, 56, 60. Then we have 65, 75, 82. 65, 75, and 82. Perfect. Now we find out quartile. Now quartile here is Q3 minus Q1. So Q1 we had discussed already. Quartile means it divides all the numbers into 4 categories, all the observations into 4 parts. So Q is nothing but n by 1 by 4th observation. This is Q1. Okay, the first quartile. So here the first quartile, n is how much? N is 10. So n plus 1 means 10 plus 11 by 4. That is 11 by 4th observation. 11 by 4th observation means it is basically 11 by 4 means 2.75. So it is 2.75th observation. That means it is the second observation. I'm writing second observation plus it is the second observation OBS plus 0.75 into the term 3 minus term 2. So second observation means term 2. So here the second observation, if you see, we can find out it is 42, 35 and then 42. So 42 I'm taking plus term 3 minus term 2 into 0.75. So 0.75 into term 3. Term 3 is 48. 48 minus 42. 48 minus 42. So what am I getting? Please note 42 plus 0.75 into 48 minus 42. That is equal to 42 plus 0.75 into 6, because 48 minus 42 gives you 6. So it comes out to 46.5 approximately. We're getting 46.5. This is the value of Q1. Okay, now third quartile, because we know quartile deviation is what? Q3 minus Q1. So Q1 we have got. But Q3 is what? Q3 is nothing but 3 into n plus 1 by 4. It is the third quartile. So 3 into n plus 1 by 4, that means here it will be, you can see it will become 6 points. Here is 2.75, which we have got into 3. So it will become 8.25, 8.25th of the observation. So I'm writing Q1 is 46.5. This is, we have already got this Q1. Now we are trying to find out Q3. Q3, you can see, is 8.25th. That means it is term 8 plus 0.25 into term 9 minus term 8. Term 8 plus 0.25. This is 8.25. I'm breaking 8 is coming here, and 0.25 means the difference into term 9 minus term 8. Term 8 is how much? 1, 2, 3, 4, 5, 6, 7, 8. I'm getting 65 as term 8 plus 0.25 into next term is 75. So 75 minus 65. Okay. So if this is the way we solve it, let us just go into the calculation and check. So 65 plus 0.25 into 75 minus 65, that is 10. 0.25 into 10 is 2.5. So therefore, 65 and 2.5, that gives you 67.5. So I'm writing Q3 is 67.5. Now we rub up this part and we calculate the last part, that is the quartile deviation. Okay. Now we will find out quartile deviation. So we know quartile deviation QD is equal to Q3 minus Q1 by 2. Q3 minus Q1 by 2. What is Q3? 67.5. How much is Q1? Q1 is 46.5. Divide by 2. So I'm getting 67.5 minus 46.5 by 2. Okay. So basically this works out to 21. 21 by 2, that is 10.5. So we have got the same answer, 10.5. Yes, many of you have got it. Great. 10.5. Jaspreet, Shiba, Ankit, Dhara, Muhammad Ali, Priyanka, Dhyanesh, then Abdul, Shiba. Very good. Excellent. Yes. Now you have to find out coefficient of quartile deviation. So it is 10.5 divided by, we add up now 67.5 plus 46.5. So 67.5 plus 46.5 into 100. So if you multiply that by 100, we're getting 18.42. Achha. Now we get the next question which has come up on the slide. Very, very important. So I hope you have understood the entire working out of quartile deviation. Now this is a very important question which is there on the slide. 14.2.19. If the quartile deviation of X is 6 and the equation is given, what is the quartile deviation of Y? Very, very relevant question for the exam, and please practice these type of questions along with the calculation based question like the one we are doing. So many tables we drew, so many problems we have solved. That is the problem based, these are a lot of calculation based questions, but this one 14.2.19, this is based on the formula. So this is not going to be lengthy in calculation, just using the formula. So it is given 3x plus 6y is 20. 3x plus 6y is 20. And we know quartile deviation of x is 6. So QDX equal to 6. We have to find QDY. We don't know. This is to be found out. We know this and this is given. So from this equation, I can write, please remember the form is y equal to a plus bx. A plus bx. So I can write it like this, 6y is equal to 20 minus 3x. 3x comes to this side. Now I can write it like this, y is equal to 20 by 6. I'm dividing right hand side by 6. Minus 3 by 6. Minus 3 by 6 into x. So this is now, you see, this is A and this part is B. In fact, I will put plus here and I will put minus inside. So 20 by x, 20 by 6 plus of minus 3 by 6 into x. So this is A plus bx. You can see this is of the form A, this is A plus B into x. A is 20 by 6 and B is minus 3 by 6. Okay, I hope it is clear. So we have to find out QDY. QDY is very simple. It is just equal to mod B into QD of x. Here mod B is how much? 3 by 6 into QD of x. QD of x is 6. So answer should be 3. Okay, let's see the answer. Answer is 3. Yeah, many of you have got it. Good. QD is 3. Yeah, Abdul, Bhumika, Jyoti, Dhyanesh. Very good. Now we come to the last part, which is the MCQ set A. First, we will take some of the theory questions. Like some of you are asking what type of theory questions can be expected on this chapter. So let's look at the theory questions. Now, first and foremost, let us take which measure, this one, number 9 from MCQ set A. Which measure is based on only the central 50% of the observation? SD, no. SD is based on all observation, number 1. Mean deviation also no, based on all observation. Only quartile deviation is based on central 50 because the formula is Q3 minus Q1 by 2. Okay, so therefore the answer is quartile deviation. Next question, which measure of dispersion is based on all the observation? Is it mean deviation? Is it standard deviation? Is it quartile deviation? Is it A and B but not C? Now, already looking at number 9, you can guess that quartile deviation is based only on the central 50. So quartile deviation is not the answer. So the answer is mean deviation and standard deviation, because in both these cases, they consider all the observation. So answer is A and B. That means option number D is the right answer here, because option number D states A and B but not C. The next question is number 11. I hope you can see the type of theory questions. Good. Yeah, Ankit, good that you've got it. Good. I hope you have understood. The appropriate measure of dispersion for open-ended classification. Open-ended classification means ideally that classification where there is no upper limit. So it's open-ended, 60 and above, say for example. So it's open-ended. In such a case, only quartile deviation will help us. So in this case, the answer is option number C is the right answer. So you can see the theory questions are quite important, and definitely if you go through the theory, I've always tried to tell you that apart from solving the problems which we do together, you on the other side, I on this side, we do it together. We are all learning mathematics and statistics together, not a problem. We do all these calculations, but apart from that, we should always remember the theoretical part. You can see set A, the Board of Studies has already given us a hint through the set A that there can be questions on theory. And these are easy because theory questions means it is there in your mind. You don't have to do any working out. You don't have to even, even little bit of rough work you don't need to do. It's all there. It's a direct formula based question, or it's a concept based question. So you will take less time to solve the theory question, right? So that is the benefit of a theory question. Next is, which measure of dispersion has some desirable mathematical properties? Okay. Now here, mostly we will see that standard deviation is the best in terms of mathematical properties, because we could do that particular problem, we did, where there are two classes of two groups, N1, N2. Standard deviation is sigma 1, sigma 2. We wanted to find out the combined, dispersion, combined standard deviation. So standard deviation is the right answer. 14th question, this is also very intelligent. If the profits of a company remain the same for the last 10 months, standard deviation of the profits will be what? If the profits are same, then deviation is, there's no deviation. If deviation is 0, then standard deviation will be 0. Okay, so if we are getting the same, say, profit every year, or you are getting the same marks in, say, IPCC foundation, in, say, standard 12 foundation IPCC final. So there is no deviation in your marks. You are getting the same marks. So we know deviation is equal to x minus that particular, either assumed mean, or we take the mean. So if there is no deviation, that means you are getting the same marks. So therefore the standard deviation has to be 0. Okay, this is also interesting question. 16th question, a shift of origin has no impact. Okay, the shift of origin has absolutely no impact on any of these. Now, like we did here, please note, shift of origin means this part, 20/6. This is the shift. This is the shift in origin. This is not considered at all. Only this B is considered. Only this B is considered. B means it is basically, you can say, the multiple, the multiplier effect. And the shift in origin is this. It is not affected because we never calculate, we never consider this 20/6. That means the component A, this is A. This component is never used for finding out the, say, mean deviation or the range or the standard deviation of Y. When the standard deviation, mean and mean deviation is known to you, or the range is known to you for X, when we find out the range, mean deviation and standard deviation of Y, given the values of X, we only consider B. Modulus B is the formula. Please see, modulus B. So we never consider A. So therefore, shift in origin, which is measured by A, is not used at all. Therefore, the answer is all of them, they have no impact. If there is a shift of origin, it has got no impact on range, mean deviation, and standard deviation. Another beautiful question has come. If all the observations are increased by 10, then SD would be increased by 10, mean deviation would be increased by 10, QD would be increased by 10. All these remain unchanged. The answer is, since there is no change, there is no impact due to change in the shift. So even if you increase it by 10, there will be no impact on the standard deviation, mean deviation, and quartile deviation. They will remain the same, because as I said, even if you have A, there is no impact of the shift in origin. A has no difference. So instead of 20, if it is 50, 50 by 10, no difference. 50 by 6, no difference. Okay. So shift in origin has no impact. Now we move to set B. Yes, many of you are answering. Thank you, Priyanka, Jasprit, Shiba. Yeah, very good. Excellent. Set B. If the SD of, now we will try to quickly work it out, and requesting all of you to work it out with me, those who are following this session. If the SD of x is 3, what is the variance of 5 minus 2x? Be very careful. They are asking you to find the variance, not the SD. So you have to get the square. So if SD of x is given and y is given, y is equal to 5 minus 2x. So it is of the form a plus bx. Here you can see, if I just consider the value of b, here b is equal to minus 2. So the value will be the SD of y is equal to mod b into the SD of x. SD of x is how much? It is given 3. So, and mod b is minus 2. So it becomes 2. The sign is ignored. We'll take the positive sign. 2 into 3, because SD of x is 3. So I get 6. SD of y is 6, but you have to find out the variance of y. So the variance is equal to 6 squared, that is 36. Okay, so let's check the question. Options are given: 36, 6, 1, and 9. Answer is option A. Next question, if x and y are related, it is given number 15, 2x plus 3y plus 4 equal to 0. SD of x is 6. What is the SD of y? Same type of formula. The same formula we are using, y equal to a plus bx, and we will just work it out. So here we are given 2x plus 3y plus 4 is 0. 2x plus 3y plus 4 is 0. So we can write 3y is equal to minus 4 minus 2x. That is, y is equal to minus 4 by 3 minus 2 by 3 into x. We are simplifying. So it is given that SD of x is 6. So SD of y, that is sigma y, is equal to mod b into sigma x. Mod b is this one, minus 2 by 3. We will ignore this minus sign. We'll take the positive sign. So I'll write 2 by 3 into sigma x. Sigma x is 6. So it comes to 4. Answer should be 4. Option is B is the right answer. Okay. Yes. Very good. Yeah. Chandan, thank you. You have got 36. Very good. Also, we have got Dhara and Jasprit. So all are doing so fast. It is so good to see all of you working continuously. And that is how we get the confidence on our efforts, and we get ready for the exam. The next question, let me take up number 16. The quartiles of a variable are given. Its quartile deviation is how much? Okay. First quartile, second quartile, third quartile, all are given. You have to find out the quartile deviation. So Q1 is 45, Q2 is 52, and Q3 is 65. Quartile deviation you have to find out. Quartile deviation is Q3 minus Q1 by 2. So Q3 is 65. I will take 65 here minus Q1. Q1 is 45 by 2. So it is 20 by 2, that is 10. Answer should be 10. Let me check the answer here. Oh, yeah. So option A is the right answer, 10. Next one, number 17, important question. If x and y are related as 3x plus 4y equal to 20. Okay, we just take up this question. So it is given that 3x plus 4y equal to 20. Fine. Quartile deviation of x is 12. So QD x is 12. You have to find QD of y. Right. So the same formula we use. y equal to a plus bx. So I can write 4y equal to minus 3x plus 20. That is, y can be written as minus 3 by 4 into x plus 20 by 4, that is 5. So here b is minus 3 by 4. So QD y, that is quartile deviation of y, is equal to modulus b into quartile deviation of x, right? I hope you are following, and you can see this quartile deviation of y is equal to mod b, that is 3 by 4 into quartile deviation of x. X is 12. Q dx is 12. So 3 by 4 into 12, so 4, 3, you get 9. Let's see the answers. 16, 14, 10, and 9. Let's see the option. Option is D. Answer is 9. Okay. Next question is the relation between x and y is 5y minus 3x equal to 10, and the mean deviation about mean is x equal to 12. Then mean deviation of y about mean is how much? So let us see the options. This is on mean deviation. Okay. So we will use the same formula here, and it is given that if 5y minus 3x, 5y minus 3x equal to 10. Okay, 5y minus 3x equal to 10. Very good, excellent performances. Bhumika, Dhara, Manisha, Shiba, Priyanka, Dhyanesh, Abdul, Chandan, Jaspreet, Ankit, all are working hard and giving the answers. Excellent. So if the relation between x and y is this and the mean deviation is this, what is the mean deviation of y about mean? So we know the mdx is given, it is 12. So here again, it's very simple. We just use the same formula. 5y will be equal to 3x plus 10. That is, y is equal to 3 by 5 x plus 2, because 10 by 5 gives you 2. So we are concerned only with this part, 3 by 5, okay, because that is the modulus b. So here it is mdy, mean deviation of y will be modulus b into the mean deviation of x. So it is 3 by 5 into 12. So 3 by 5 into 12 means 36 by 5. So should be 7.2, I think should be the answer. Let's check. Yeah, answer A is right answer, 7.2. Next one. Acha, this is also very important question. Please try this one. If two variables x and y are related and the mean and mean deviation about mean are given. So we have to be careful with this. You have to find two values. This is very, very important question. 2x plus 3y minus 7. 2x plus 3y minus 7 is 0. It is given. Mean of x and mean deviation is given. Please note mean of x. Mean of x is 1. Mean deviation of x is 0.3. You have to find coefficient of mean deviation of y. Okay, coefficient of mean deviation. So we have to do it by steps and by some simple steps. First is we take 3y. This 3y is equal to 7 minus 2x by transposing. So y is equal to 7 by 3 minus 2 by 3x. Okay. So first of all, please note that here we have to first find the mean of y. So mean of y will be 7 by 3 minus 2 by 3 into mean of x. Mean of x is 1. So it is 2 by 3 into 1. So mean of y is 7 by 3 minus 2 by 3, that is 5 by 3. So we can write mean of y is 5 by 3. Second, this is number 1 for number 1. Fact, the first data number 1. Now data number 2 is what? We are calculating mean deviation. So mean deviation of y will be equal to modulus b into mean deviation of x, right? Modulus b is 2 by 3. So 2 by 3 into mean deviation of x. Mean deviation of x is 0.3. That is 3 by 10. So 3 and 3 cancels. So I get 1 by 5. So please note, we have got two figures now. The mean of y is 5 by 3 and the mean deviation is 1 by 5. You have to find the coefficient of mean deviation. Dear friends, we know coefficient of mean deviation is given by MD by mean into 100. So here MD, that is mean deviation of y, is how much? It is coming to 1 by 5. 1 by 5 divided by the mean is 5 by 3. So divided by 5 by 3, that means we can write into 3 by 5 into 100. So 5 is 25, 25 4s are 100, 4 3s are 12. So the answer is 12. Okay, so this is a longer question, you can see, and it is based on 2 facts and figures. Yes, well done. Okay, Shiva, great, you have done it. Very good. MD of Y, yes. Chandan, Jasprit, Dhara, all are writing answers. Okay. So mean we have done. Number 19, if X and Y are related by this and the SD and AM of coefficient of variation we have to find out. We have to find out CV, coefficient of variation. X and Y are related, SD and AM are known. So we have to find out the coefficient of variation. Achha. The formula is, the relation is y equal to 2x plus 5. Let's work it out. Y equal to 2x plus 5. Okay. It is given. What are you given? Which data is given? SD and AM. SD is 5 and AM is 10. So I can write SD of x is 5 and mean, that is mu x is 10. Fine. We have to find the coefficient of variation of y. Now we know coefficient of variation is equal to sigma by mu, SD by mean into 100. So we need SD as well as mean for y. Mean of y is equal to how much? Now the formula is y equal to 2x plus x. So the mean of y will be equal to 2 into mean of x plus 5. That is 2 into 5 plus 5. That is 15. I'm getting mean of y equal to 15. Okay, we are getting mean, that is mean of y is equal to 15. First relation or first data we have got. Now we need to find out the second one, that is standard deviation. Standard deviation, so sigma y will be equal to mod b into sigma x. So sigma y is mod b. Mod b is how much? Mod b is 2. 2 into sigma x. Sigma x is 5. 2 into 5, that is, I'm getting 10 here. So now we have got mean is 15 and SD is 10. Okay, so therefore we have to find out what is the coefficient of variation. So we can write coefficient of variation is sigma by mean into 100. Sigma is 10. 10 by mean, 10 by 15 into 100. Okay, so we are getting 10 by 15 into 100. Okay, now let us go into the next one. Okay, AQB, we go to the last part, that is AQB part, and in AQB we are taking the first problem here. Mean is of dash types. We are taking number of problems here. Mean is of how many types? So the options are given 3, 4, 8 and 5. Now we know that the mean is basically arithmetic mean, geometric mean and harmonic mean. So there are 3 types. So answer 3, that is option A. The algebraic sum of deviations of observations from their arithmetic mean is how much? 2, minus 1, 1 or 0. We know the algebraic sum of all the deviation from the AM will always be 0. So the answer is 0. Okay, so the answer is 0. Option D is the right answer. GM of 8, 4 and 2 is how much? GM of 8, 4 and 2 is how much? So you remember we did geometric mean, many problems we have done on geometric mean. So 8, 4 and 2. So it is the cube root of 8 into 4 into 2. So that gives us 4 8 is 32 is 64. Cube root of 64 is 4. So the answer is 4. GM number 10 is 4. Next one, number 14, value of the middlemost item when they are arranged in order of magnitude is called what? When they are arranged in order of magnitude, That means from smaller to bigger or from bigger to smaller. The middle most item is called median. So option D is the right one. Okay. Next, yes, 10th one is 4. Thank you, Priyanka. 10th one is 4. Also, Chandan, very good. Now we move to the 17th one, the value which occurs with the maximum frequency. We know that the observation which comes with maximum frequency is known as mode. Okay, so the option here is B, option B, that is mode. So option B is the right answer, mode. The next problem coming up is mode of the observations have to be found out. Question number 22 from the additional question bank. 25843445244. If you see here, 4 is coming maximum number of times. Okay, it's multimodal distribution. We have more than one digit which is coming repeatedly, but 4 is coming for the maximum number of times. 4 is repeated for the maximum number of times. It is 5 times. Therefore, the mode is 4. Options are 3, 2, 5, and 4. Option D is the right answer. 36. Deviation may be positive or negative or 0. Is it false, true, both, or none? Well, deviation we have already worked out. It can be positive, it can be negative or 0. So it is true. Option A. 42nd question. AM of 8, 1, and 6. Just mentally also you can do without writing. 8 plus 1 is 9, 9 and 6 is 15, 15 divided by 3 is 5. Option A is the right answer. 58th question, the class in which mode belongs is known as what? We have done that problem. These type of problems, you know, it is known as the modal class. That class which has maximum frequency will be the modal class. It's called the modal class because mode belongs to that class. Next is number 62, relation between mean, median, and mode. Here comes that question which I was talking about, very important. Mean minus mode will be equal to 3 into mean minus median. So if you see carefully, option number D is the right answer. Mean minus mode equal to 3 into mean minus median. Question number 70 from additional question bank. Dash is the value of the variable corresponding to the cumulative frequency n by 2. N by 2, yes, many of you are continuously solving. Jaspreet, Ankit, Chandan, Priyanka, excellent. Thank you. Bhumika, excellent. Very good. Number 70, dash is the value of the variable corresponding to the cumulative frequency n by 2. N by 2, you can easily understand the hint. The hint is it is median. So option C is the right answer. In question number 70, option C. Next is number 93. Question number 93. The 10th percentile is equal to what? 10th percentile means it is the first decile because percentile divides the entire observations into 100 parts. 10th percentile means it is the 10th, basically the 10th observation, that is the first decile. Okay. Next one, 50th percentile. 50th percentile will be known as we can say it is the 50th percentile is the middlemost. 50th percentile means the 50th observation. That is, it is out of 100, the 50th, that is middlemost. So it is the median. Option D is right answer. Number 94. Number 136, dash deviation is called semi-interquartile range. We have just done that, quartile deviation. Option C. 141st question, coefficient of variation is SD by mean into 100. Yes, it is true. We have done that problem, SD by mean into 100. And please remember, mean deviation divided by mean into 100 is basically called the coefficient of mean deviation. Okay. Now we come to the last group. A measure of central tendency tries to estimate what? Is it the central value, lower value, upper value, or none? It actually identifies the central value. Please remember that, central value. Option A. Also, number 48, the measures of central tendency are known as what? Measures of central tendency is known as average. It is called the science of averages, law of averages. So option B is the right answer. Option B. And 229th question, the square of standard deviation is known as what? It is known as variance. We have done that. VAR, as we write it, VAR, is nothing but sigma square. That is square of standard deviation. And the last one, for values which lie close to the mean, the standard deviation usually will be what? Big or small or moderate or none. Well, for the values which lie very close to the mean, what happens? It means that there is absolutely very little dispersion. Very little dispersion means what? It means that the spreading out is very low, much on the lower side. Therefore, for values which lie close to the mean, the standard deviation will be small, right? So thanks a lot to all of you for having all these central value. All of you, Manisha, Ankit, Priyanka, Jaspreet, then we have Shiba, then continuously people are writing the answers. Very well done. Chandan, Abdul, all of you, thank you, and good, very good practice we could do together. So with that, we wind up the session, and we have completed the measures of central tendency and the measures of standard of deviation, dispersion. We have completed the detailed discussion of range, mean deviation, standard deviation, quartile deviation, along with the analysis of the advantages, disadvantages, and the properties. Good that we could also take almost all the queries and the questions which came. We were able to consider and provide you with the clarification, and sometimes I did the problem once again to help you out. Good, we could complete successfully these 2 chapters, and in the next session we will move into probability. I think that's on 23rd of February, 25th of February, we will move into probability, and we have 2 sessions for probability, which is yet another very important chapter as well as interesting chapter. So till then, thank you, thanks to all of you, and see you soon. Bye.